Hi friends, welcome to our final discussion here in our solutions unit. Here in lesson 3 we're going to talk about colligative properties, which you may not be familiar with yet, but you have seen them in action. You may notice that when it snows around here, one of the things that we do is to put down salt on the roads, and that this salt causes the snow on the roads to melt. Have you ever wondered why that happens? It has to do with colligative properties. Let's go in and take a look. Colligative properties refer to any property of a solution that depends only upon the concentration of the solution, not upon the chemical nature of the solute. We're only going to look at two colligative properties in this class. We're going to look at boiling point elevation and freezing point depression. In both cases, the changes that we see are due to what we call solute interference, which is just interfering interactions between solute and solvent particles. When a solution boils, the solute particles that are in that solution are actually going to interfere with the solvent particles and make them less likely to enter the gas phase. This has to do with those molecule solute attractions, like the molecule ion attractions that we talked about in lesson 1. In order to disrupt what we call the hydration shell, the surrounding of solute particles by water molecules, we have to put in additional energy to disrupt that shell and allow those water molecules to enter the gas phase. When a solution freezes, the solute particles interfere by getting in the way of the solvent particles as they form the crystal lattice, that regular repeating three-dimensional structure that is characteristic of the solid phase of any substance. The more solute particles that we have, the more that those particles interfere with the formation of the solvent's crystal lattice, and the more energy we have to remove before a solid can form. The bottom line is this. As the concentration of a solution increases, the boiling point of a solution is raised, and the freezing point of a solution is lowered. You see this phase diagram for a particular liquid solvent, and you can see that that liquid in solution has a higher boiling point and a lower freezing point than that liquid as a pure solvent. Does this make sense? If it doesn't, write down any questions that you have before we move on. What's really important to understand is that different substances will form different numbers of particles when they dissolve. This is because many substances will break apart into ions when they dissolve in solution, which is what we call dissociation. Substances that dissociate into ions in solution are going to produce more particles, and so as a result, they're going to have a larger effect on the boiling and freezing point of a solution. Let's take a look at some examples to see what we mean. I've got 3 different solutes here. I've got 1 mole of glucose, 1 mole of sodium chloride, NaCl, and 1 mole of magnesium nitrate. Let's look at the number of particles that they produce. 1 mole of glucose is going to produce 1 mole of glucose particles in solution, because glucose does not dissociate when it enters into solution. The glucose molecules remain intact. Sodium chloride, on the other hand, is going to produce 2 moles of particles, 1 mole of sodium ions and 1 mole of chloride ions, because sodium chloride dissociates into its constituent ions when we put it into solution. For the same reason, magnesium nitrate is going to produce 3 moles of particles, 1 mole of magnesium ions and the 2 moles of nitrate ions. If we consider equal volumes of aqueous solutions of these 3 substances, moving from left to right in this diagram, the boiling point will increase for the solution and the freezing point will decrease. That's because we get more particles in the solution as we move from left to right. Does this make sense? If it doesn't, take a moment and write down any questions that you have before we move on. The only other thing that you need to be able to do with respect to colligative properties is to determine the boiling point elevation and the freezing point depression. For colligative properties, the most useful concentration measurement to use is molality. As a reminder, molality is defined as moles of solute per kilogram of solution. Once we know the molality of the solution, we're going to multiply that by the number of particles, which is represented as I, the characteristic temperature values for a particular solvent, and really we're only interested in water. So for water, the freezing point decreases by 1.86 degrees Celsius per mole of particles in the solution, and the boiling point increases by 0.52 degrees Celsius per mole of particles in the solution. Let's try an example that looks at this. This is on page 13 of your Unit 10 packet. What is the freezing point and boiling point of a 2.0 molal solution of calcium chloride? Pause the video, try it on your own, and then when you're ready, we'll go through it together. So let's do freezing point first. I know that the normal freezing point of water is 0 degrees Celsius, and I'm going to subtract from that the freezing point depression, 1.86 degrees Celsius, multiplied by the molality of the solution, multiplied by the number of particles of this particular solute. Plugging in my values, I get 1.86 degrees Celsius times 2 molal times 3 particles, 1 calcium and 2 chloride ions in my solute. Doing that math, I get 0 minus 11.16 degrees Celsius, and my final freezing point for this solution is going to be negative 11.16 degrees Celsius. Now let's do the boiling point. Boiling point is going to be equal to the normal boiling point of water, 100 degrees Celsius, times the boiling point elevation, 0.52 degrees Celsius, times the molality of the solution, times the number of particles. Plugging in my values, I get 0.52 times 2 molal times 3, which winds up being 100 degrees Celsius plus 3.12 degrees Celsius for a final boiling point of 103.12 degrees Celsius. Does this make sense? If it doesn't, take a moment and write down any questions that you have before we wrap up. Thanks so much for watching our third and final discussion here in our solutions unit. Make sure you can do the following things here at the end. Make sure you can explain how and why the boiling point and freezing point of solutions are affected by the concentration of solute particles in those solutions. Also make sure that you can determine the number of particles that different solutes will produce when we put them into aqueous solution. And finally, make sure that you can calculate the freezing point and boiling point of aqueous solutions if you're given the molality of those solutions. If you can do all those things, you're doing great. If not, that's okay too. Take a moment and write down any questions that you have. You can always leave them in the comments below the video, and you can always get in touch with me. Thanks again for watching. I really appreciate it. Have a great day.